Software quality assurance, or SQA, is a critical discipline in software development, ensuring that software products meet predetermined quality standards. Measurement plays a pivotal role in SQA, providing valuable insights into the software development process and product quality. By quantifying key aspects of software development, measurement enables informed decision-making, process improvement, and ultimately, the delivery of high-quality software. Without measurement, SQA becomes subjective and prone to inconsistencies. Objective data, derived from various metrics, provides a clear understanding of project status, areas for improvement, and the effectiveness of quality assurance efforts. Measurements enable teams to track progress, identify bottlenecks, and make data-driven decisions to enhance software quality and development efficiency. The insights gained from measurement empower software development teams to optimize their processes, reduce defects, and deliver software that meets customer expectations. By establishing benchmarks and tracking metrics over time, organizations can monitor their progress, identify areas for improvement, and demonstrate the effectiveness of their quality assurance initiatives. In essence, measurement provides the necessary visibility and accountability to ensure the delivery of high-quality software products. It empowers teams to make informed decisions, optimize processes, and continuously improve the software development lifecycle. Defect metrics play a crucial role in software quality assurance by providing insights into the number and nature of defects present in a software product. These metrics help teams identify areas of the code base that require attention, track the effectiveness of defect removal activities, and ultimately improve the overall quality of the software. One commonly used defect metric is defect density, which measures the number of defects per unit of software size, such as lines of code or function points. A high defect density may indicate potential quality issues and areas where development practices need improvement. Another important metric is defect severity, which categorizes defects based on their impact on the software's functionality. Tracking defect severity helps teams prioritize defect resolution efforts, focusing on critical defects that could significantly impact users. By analyzing defect trends over time, teams can identify potential problem areas, assess the effectiveness of quality assurance activities, and make necessary adjustments to their processes. Defect metrics provide valuable data for process improvement initiatives. By understanding the types of defects that occur most frequently, teams can identify root causes and implement preventive measures. This data-driven approach to defect management helps reduce the number of defects introduced during development, leading to higher quality software. Test coverage metrics are essential in software quality assurance, as they provide insights into the extent to which the source code of a program is tested by a particular test suite. High test coverage is crucial for ensuring that software is thoroughly tested, reducing the likelihood of undetected defects and improving overall software quality. Various test coverage metrics exist, each focusing on different aspects of code coverage. Statement coverage, for example, measures the percentage of statements in the source code that have been executed during testing. Branch coverage, on the other hand, measures the percentage of branches, decision points, that have been exercised. Path coverage goes further by measuring the percentage of all possible execution paths through the code that have been tested. Achieving 100% coverage for all metrics is often impractical due to the complexity of software. However, aiming for high coverage, especially in critical areas of the codebase, significantly increases the probability of finding defects. Test coverage metrics not only help ensure comprehensive testing, but also guide testing efforts by identifying areas of the code that lack sufficient test coverage. This information allows teams to focus their testing efforts on critical areas, optimizing testing resources, and maximizing the effectiveness of their testing strategy. Code complexity metrics play a vital role in software quality assurance by assessing the complexity and maintainability of source code. Complex code can be difficult to understand, modify, and test, leading to increased development time, higher defect rates, and reduced software quality. One widely used code complexity metric is cyclomatic complexity, which measures the number of linearly independent paths through a program's source code. A high cyclomatic complexity indicates a greater number of decision points and potential paths of execution, making the code more challenging to understand and maintain. Another important metric is code churn, which measures the number of times a particular line of code has been modified. High code churn may indicate areas of the codebase that are prone to errors or require frequent updates, suggesting potential design flaws or the need for refactoring. By monitoring code complexity metrics, development teams can identify areas of the codebase that may require refactoring or simplification. Reducing code complexity improves code readability, maintainability, and testability, leading to fewer defects, easier debugging, and faster development cycles. Productivity metrics are essential in software quality assurance as they provide insights into the efficiency and effectiveness of the software development process. By measuring productivity, organizations can identify bottlenecks, optimize resource allocation, and improve overall development throughput. One commonly used productivity metric is lines of code, or LOC, written per unit of time, such as per day or per week. While LOC alone may not fully capture the complexity of software development, it can provide a general indication of developer output. Another important metric is function points, which measure the functionality delivered by the software. Function points provide a more comprehensive view of productivity as they consider the complexity and value of the delivered features. Tracking productivity metrics over time allows organizations to identify trends, assess the impact of process changes, and make data-driven decisions to improve development efficiency. By understanding factors that influence productivity, such as team size, experience level, and tool sets, organizations can optimize their processes and allocate resources effectively. Improved productivity not only accelerates development cycles, but also frees up resources for other critical tasks, such as quality assurance and testing. Requirements traceability metrics play a critical role in software quality assurance by ensuring that all requirements are properly implemented and tested. These metrics establish a clear link between requirements, design elements, code, and test cases, providing end-to-end visibility throughout the software development lifecycle. One important metric is requirements coverage, which measures the percentage of requirements that have corresponding test cases. High requirements coverage ensures that all aspects of the software's intended functionality are thoroughly tested, reducing the risk of undetected defects. Another important metric is traceability depth, which measures the level of detail in the traceability links. Detailed traceability links provide a comprehensive audit trail, making it easier to identify the root cause of defects and assess the impact of changes. By tracking requirements traceability metrics, teams can ensure that all requirements are met, reducing the likelihood of costly rework and delays. Traceability also facilitates impact analysis, allowing teams to assess the potential consequences of changes and ensure that modifications do not introduce new defects. Customer satisfaction metrics are paramount in software quality assurance as they provide direct feedback on the quality and usability of the software from the end user's perspective. Measuring customer satisfaction helps organizations understand user needs, identify areas for improvement, and ultimately deliver software that meets user expectations. One widely used customer satisfaction metric is the Net Promoter Score, or NPS, which measures the likelihood of customers to recommend the software to others. NPS provides a simple yet powerful indicator of overall customer satisfaction and loyalty. Other important metrics include customer satisfaction surveys, which gather detailed feedback on specific aspects of the software, and user feedback forums, which provide a platform for users to share their experiences and report issues. Analyzing customer feedback allows organizations to identify areas where the software excels and areas where improvements are needed. By incorporating customer feedback into the development process, organizations can enhance user experience, improve software quality, and increase customer satisfaction. Customer-centric development practices lead to software that is not only functional, but also meets the needs and expectations of its intended users. Process compliance metrics are essential in software quality assurance as they ensure that software development processes adhere to established standards, regulations, and best practices. Compliance with industry standards and internal guidelines is crucial for maintaining software quality, reducing risks, and meeting legal or contractual obligations. One important aspect of process compliance is tracking defect removal effectiveness. which measures the percentage of defects detected and removed during each phase of the software development lifecycle. High defect removal rates in early phases, such as requirements and design, help prevent costly defects from propagating to later stages. Another critical metric is compliance with coding standards, which ensures that source code adheres to predefined style guidelines and best practices. Consistent coding practices improve code readability, maintainability, and reduce the likelihood of errors. By monitoring process compliance metrics, organizations can demonstrate adherence to industry standards, meet regulatory requirements, and ensure the quality and reliability of their software products. Process compliance fosters a culture of quality, reduces risks, and enhances the overall efficiency and effectiveness of software development. The various metrics discussed in this essay collectively contribute to enhancing the overall quality and reliability of software products. By providing objective data and insights into different aspects of software development, these metrics enable informed decision-making, process improvement, and a data-driven approach to quality assurance. Defect metrics help identify and track software imperfections, allowing teams to focus on areas that require attention and improve defect removal activities. Test coverage metrics ensure comprehensive testing, reducing the likelihood of undetected defects and increasing confidence in the software's functionality. Code complexity metrics guide efforts to simplify and improve code maintainability, leading to fewer defects, easier debugging, and faster development cycles. Productivity metrics provide insights into development efficiency, enabling organizations to optimize processes and resource allocation. Requirements traceability metrics ensure that all requirements are met and properly tested, reducing the risk of costly rework and delays. Customer satisfaction metrics provide valuable feedback from the end user's perspective, guiding improvements to user experience and overall software quality. Process compliance metrics ensure adherence to standards, regulations, and best practices, fostering a culture of quality and reducing risks. In conclusion, measurement is an indispensable aspect of software quality assurance, providing the necessary insights to deliver high-quality software products. By quantifying key aspects of software development, organizations can make informed decisions, optimize processes, and continuously improve the software development lifecycle. Embracing measurement enables software development teams to move from subjective assessments to objective data-driven evaluations, fostering a culture of quality and accountability. The insights gained from various metrics empower teams to identify areas for improvement, track progress, and demonstrate the effectiveness of quality assurance efforts. As software continues to play an increasingly critical role in our lives, the importance of software quality cannot be overstated. By embracing measurement and incorporating it into all phases of software development, organizations can deliver software that is reliable, functional, and meets the needs of its users. Measurement is not merely a task, but a continuous journey towards software excellence.